Yeah, she now rockin' with Mr. Wit. A little flavor from Q Beats, you know that this a hit. Michael Jackson bad, yeah, this is it. A few months ago I was about to call it quits, until I came across personalized math tutoring. FBT, the #1 solution. So what you waiting on? Everything is online.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be on subtracting matrices. That's right, we're going to be subtracting matrices, and I have one right here. Number 1, we have the matrix 12, -5, 10, 3 minus the matrix 6, 9, -2, and 0. The first thing you need to keep in mind is that you can only subtract matrices that have the exact same rows and columns. If you check out our first matrix here, our first matrix contains 2 rows. See, the rows are horizontal entries, whereas the vertical entries are what you call your columns. The dimensions of your matrices have to be identical in order for you to subtract them. So because this first matrix is a 2 by 2 matrix, so I'm going to go ahead and write that as 2 by 2 right here, minus the second matrix, which is also a 2 by 2 matrix, meaning that this matrix has 2 rows and 2 columns, and so does the other one. So in order to subtract these, I actually prefer to rewrite this problem as the sum of 2 matrices by distributing the scalar -1. That's right. See this minus sign right here? Yeah, it's also the scalar -1. Rewriting the original expression as an addition problem, I'll have 12, -5, 10, 3, plus the result of multiplying the scalar -1 times every entry in the second matrix. So you'll end up with -6, -9, +2, and 0. So now I have rewritten the problem as the addition of 2 matrices. And if you need assistance adding matrices, just check out this link right here. Go ahead and click on that. All right, check that out. So in order to find the sum of these 2 matrices now, we'll be combining the corresponding entries. So what I mean by that is 12, here, let me go ahead and show you again. The 12 in the first row, first column can be combined with the -6 in the first row in the first column in the second matrix. You can add these corresponding entries together, and that's the way we'll complete the entire problem. We'll be combining the corresponding entries to find out our result. All right? So, for instance, let's just go ahead and keep that in view. We'll have 12 plus -6 for the first row and first column. We'll also have -5 plus -9. Then for the entry that we'll have in the second row, first column, I'll have 10 plus 2. And then finally in the second row, second column, you'll combine 3 plus 0. This will give us our result. So checking out that result, we'll end up with the following answer. 12 plus -6 is +6. 10 plus 2 is always 12. -5 plus -9, that's the same thing as -5 minus 9, which is -14. And then 3 plus 0, that's always 3. All right? So here we have our result. Now, you're absolutely right. You could have gone ahead and set up your subtraction in this row right here by saying 12 minus 6 and then saying -5 minus 9. And that would have given you the right answer, but I chose to do number 1 that way. You know what? I think you may be on to something. Let's go ahead and do our second problem just as you suggested, okay? So in our first example, I rewrote our subtraction problem into an addition problem by adding the opposite of the second matrix by multiplying every entry in that second matrix by -1. And then finding the sum by adding all the corresponding entries. But in my next example, I'll go ahead and do what you suggest. I'm going to go ahead and just subtract them and see what happens. But before we do that, we have to red box our answer. There you go. Red box it. Go ahead and do that. Just red box it. Okay? So you may be wondering, well, Mr. Witt, why did you go through all that extra stuff? Well, because sometimes people forget about that minus sign in the middle and they'll forget to distribute the negative. So one way to avoid that is to put it right in your face, go ahead and distribute the negative first, and then add your results together. So for me, it actually helps my accuracy to do that extra step. But if you're not going to forget about the minus sign each time, hey, go right ahead. Okay? Now, let's check out problem number 2. Here, I have a 2 by 1 matrix, and I want to subtract a 2 by 2 matrix from that. Okay? Remember, in order to add or subtract matrices, the dimensions must be the same. That means your rows and columns for both matrices have to line up. Well, let's go ahead and write down what the dimensions are of each matrix here. In the first matrix, I said it was a 2 by 1 matrix. That means we have 2 rows and 1 column. The second matrix, we have 2 rows and 2 columns. Those look different. They are different. You can't subtract them. So this is undefined. You don't have a difference of these 2 matrices. So you can just write down a solution that says no solution. All right? There's no solution here. Red boxing it. There you go. No solution. That U looks a little deformed. I think I'll be inclined to fix it. Say better U. Yeah, okay. That'll do. That'll do. That's problem number 2. No solution. You can't subtract them because the dimensions are different. Can't do anything with that. I'm going to move on. Moving on to problem number 3. And doesn't this look juicy? Yeah, it does. It's juicy because it's big. Okay? And we have 2 matrices that actually have the same dimensions this time. Our first matrix is a 3 by 2 matrix. Yeah, 3 rows, 2 columns. And we're going to subtract from that a matrix that also has 3 rows and 2 columns. And as you suggested, let's just go ahead and just combine all this together in one step to see if we prefer it. Okay? So I'll go ahead and show my setup is the following. That I'll have 1 minus -6 in the first row and first column. The next entry in the first row for our second column here will be -4 minus 9. See, I'm already getting a little weary here, guys, because that minus sign in the middle, you got to remember that every time you do it. Just saying. Let's continue, though. We'll have 2 minus -2. This is for the second row, first column. Then for the second row, second column, we'll have -3 minus 5. Then in our next entry, that'll be the third row, first column, we'll have -8 minus -7. Keep it in mind that we'll be taking the difference of each of the corresponding values. And then finally, you'll have 4 minus -12. All right. That's what we have thus far. Going on to our answer here for this first row, first column, let's check it out. You'll have 1 minus -6. That's equivalent to 1 plus 6. So this will be 7 here. All right. Here, the -4 minus 9 is going to give us -13 as a result. Looking at our second row, first column, we'll have 2 minus -2, which is 2 plus 2. And that's always 4. Oh, that's an ugly 4. Well, no, we won't. We won't be keeping that. There you go. That's much better. Then we have -3 minus 5. That's going to give us -8. Yeah, it will. Okay. Then you have -8 minus -7, which is equivalent to -8 plus 7. Well, -8 plus 7 is -1. All right. There it is. There it is. Then finally, we'll have our third row, second column. 4 minus -12 is equivalent to 4 plus 12, which is 16. All right, so after I did it your way, what do you think? Was this process better, even though we may have been writing fewer steps? But did it feel like you could be accurate doing it that way? I'm not so certain. I think I have more confidence doing things in steps, knowing that all I have to do in the first step is to change all the signs in the second matrix and then just add those values together. I think I may find that a little bit more comfortable, so that's the way I'm continuing. So if you like the way number 3 worked out, then continue to do it that way. Just make sure you're paying attention to that minus sign in between each time you take the difference of the corresponding entries. I'm going to red box this. Red boxing it. Just like that. That's problem number 3. All right, here we go. Now, in problem 4 here, this kind of justifies my process because you see in this problem that not only are we taking the difference of these matrices, we also have scalars involved. These are the values, these numbers that are in front of our matrices. You need to multiply every entry by the scalar before you can take the difference of the 2 matrices here, which is exactly that same process that I used in our first problem. So I think I'm going to stick with what I know. All right? It's okay. I know you don't like it. You'll be fine. You'll be okay. All right? You'll be just fine. Yeah, I know, but you'll be fine. Stop fighting me. Here we're going to multiply every entry in the first matrix by 3. Now keep in mind, both matrices had the same dimensions. So they were both 3 by 3 matrices. That's right, this first matrix up here, it's a 3 by 3. The second matrix over here, it's also a 3 by 3. And you know what? When you multiply by a scalar, it does not change the dimensions of the matrix. So keep that in mind. That's right, you over there in the back row, third seat, like nobody sees you. So multiplying this out, we have 3 times 1 is 3. And thanks. And 3 times 0 gives me 0. 3 times 3 is 9. All right, I'm having fun here. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. I can multiply. 3 times 1 is 3. 3 times 0 is 0. 3 times negative 3, it's negative 9. Okay? All right, I'm going to say plus the result I get by multiplying every entry in the second matrix by negative 4. That's right, that minus 4 here, let me put it in view for you. That negative 4, this minus 4 here, yeah, that's negative 4. I'll be multiplying negative 4 times every entry in the second matrix. Let's go ahead and see how that works out. We'll have negative 4 times negative 1, that gives me positive 4. Yeah, it does. Negative 4 times 0, it's 0. Negative 4 times 0, 0. Negative 4 times 0, 0. Negative 4 times negative 1, it's positive 4. Negative 4 times 3, it's negative 12. Okay? Negative 4 times 2 is negative 8. Thank you. And negative 4 times 0, oh, that's another 0. And negative 4 times 1, it's negative 4. Okay? There you go. So we have, together, you and I, we've rewritten our original expression, and notice we're now finding the sum of 2 matrices, and notice we no longer have any scalars to worry about, and check out the middle operation here. Check out our operation. It's a plus sign. I don't have to worry about changing the sign and all that kind of stuff, going back and forth each time. I'm going to convince you to do that extra step, okay? That's what I'm working on. All right, let's continue on. All right, so here's our previous step, and we're going to add these values together. All right, let's find the sum of this. So here we go. Okay, I'm gonna go ahead and show my steps, just saying. So for the first row, first column, I'll have 3 plus 4. Okay, there you go. Then for the first row, second column, I'll have 0 plus 0. First row, third column, I'll have 9 plus 0. Yeah, I will. Okay, from here, second row, first column, I'll have 0 plus 0, 0 plus 0, thank you. Then, second row, second column, I'll have 3 plus 4. Then, you'll have 6 plus negative 12, 6 plus negative 12, that's right there. A little ugly, but it'll do, it'll do. Then for our third row, first column, we'll have 3 plus negative 8. Third row, second column, you'll have 0 plus 0. And finally, third row, third column, you'll have negative 9 plus negative 4. All right, there you go. Finally, for our answer, we'll have 3 plus 4, which is 7. 0 plus 0 is 0. 9 plus 0, it's 9. 0 plus 0 gives me 0. 3 plus 4 is 7. And 6 plus negative 12, that's the same thing as 6 minus 12. That gives you negative 6. Yes, it does. And then you'll have 3 plus negative 8, which is the same as 3 minus 8. That gives you negative 5. Next, 0 plus 0 is 0. Finally, for the third row, third column, you have negative 9 plus negative 4. That's the same as negative 9 minus 4, which is negative 13. And this is our answer. Red box is a-coming. Don't you worry. Red boxing it. Oh, you want to see the bottom of the box? There it is. There you go. That's it. That's your answer for problem number 4. Let's move along. All right. Here's something different. In problem 5, it says, find matrix A if matrix B is the following: 4, 6, negative 5, negative 6, 3, 2, and the sum of A and B equals 6, 12, 0, negative 10, negative 4, 11. So we're already given the sum, which is A plus B, and we're given one of the matrices involved in that sum, and they want us to find the other. Well, in order to make that happen, we'll need to subtract. Isn't this a clever problem? Are you not impressed, teachers? I know you're impressed with that problem, right? Look at that, look at that, look at that. You see that? See? I came up with that one. This one was for you, teachers, okay? There you go, because that's a good problem right there. Go ahead and take that problem. All right, so let's go ahead now and find the difference of these. You'll take the sum of A and B, subtract B from that in order to obtain A. In fact, we can prove that we'll end up with our matrix A by doing the following. We can say that our sum, A plus B minus B, will give us a result that is A plus B minus B, and the B's will cancel out to give us our matrix A. It is perfect. All right, so let's put it to work. So here we're showing that we have the sum A plus B minus B, and this will give us our result, which is A. All right, let's go ahead and revert back to your method. We'll just go ahead and do it all at once. How about that? As I set it up. We'll have the entry for the first row and first column written as 6 minus 4. Then for the first row, second column, we'll have 12 minus 6. And of course, we're only allowed to do this because our dimensions of both matrices are identical. These are both 2 by 3 matrices, okay? So I'll go ahead and write that for you. Give you some type of consistency there. Then for the first row, third column, we'll have 0 minus negative 5. All right, like so. And now, moving on to our second row, we'll have negative 10 minus negative 6. Then for the second row, second column, you'll have negative 4 minus 3. Then finally, you'll have 11 minus 2. All right, that wasn't too bad. Let's go ahead and find the difference and get our answer here. So 6 minus 4, that's 2. 12 minus 6 gives me 6. 0 minus negative 5. See, the opposite of negative 5 is positive 5. So this is positive 5 here. Then negative 10 minus negative 6. The opposite of negative 6 is positive 6. And negative 10 plus 6 gives me negative 4. Negative 4 minus 3. That's negative 7. Like signs add, keep the sign of the largest digit. And finally, you have 11 minus 2. That gives you 9. Just a little old 9. I'm going to go ahead and put a box around my answer because this is it. Red box in it. That's right. This is matrix A. This is what we were looking for. Done and done. That's problem number 5. Let's look at problem number 6 now. All right, ladies and gentlemen, this is our final problem for our video on subtracting matrices. We have this, problem number 6. Let me put that in view for you. There you go. That's it. There you have it. Notice that we do have a scalar, okay? I also have a scalar of negative 1 here, okay? And since I already have one scalar here and I got the negative there, I'm definitely going to use my method of distributing the scalar first. Okay, throughout. Thank you. I'll change my entire expression here into adding matrices. All right, so that's what I'm going to do. So I'll be distributing 2 to every entry in matrix 1. And in that third matrix, I'm going to distribute that negative 1 to every entry. In other words, find the opposite of every entry in the third matrix. All right, now you do need to check to make sure that your dimensions are all the same. So what's the dimensions of the first, second, and third matrix? What do you say? What's that? No, it's not a 2 by 3. It's not a 2 by 3. The rows go before the columns, all right? So think about it. You have 1, 2, 3 rows, and you have only 1, 2 columns. See, the columns are vertical, okay? Rows are horizontal. There you go. So these are all 3 by 2 matrices. That's the dimensions of the matrices that we have before us, all right? So let's go ahead and distribute the 2 first. Here, I'll have 2 times 2 is 4. 2 times negative 1, negative 2. 2 times 5, that's 10. 2 times 1, that's 2. 2 times 0, you know it's 0. 2 times 3 is 6. And this is my first matrix. Yeah. The second matrix, we're not doing anything to that. So just bring it down as it is. Yep. Bring that thing down. And I'll have a plus sign here for my third matrix because remember, I'm going to distribute everything inside. Every entry will be multiplied by negative 1. The scalar of negative 1 right here. There you go. Remember, a minus sign is a negative sign, and that negative sign is equivalent to negative 1. Just saying. I'm multiplying on every entry in the matrix. That third one. So let's find the opposite of each entry here. So this will become -9, +4, -4, -4. Oh, I hate that -4. I'm going to fix it. -4. It's not much better, I know, but it's better for me. This is a -1 here. Then we have a -6. Yeah. There we go. That looks nice. Let's put that in view for you. Okay? All right, so what we'll do now is I'm going to show the process that I'll be using here. For instance, in the first row, first column, I'll end up with the following. I'll have 4 plus 5 plus -9. I hate that 9. Hate the 9. It's going to stay there. It's going to stay there, though. Then I'll have -2 plus 0 plus 4. Yep. Then, for the second row, first column, I'll have 10 plus 7 plus -4. Yep. Then I'll have 2 plus -3 plus -4. Go ahead and squeeze that in there. There you go. Go ahead. Had to squeeze it in. Then, thank you, I'll have, in the third row, I'll have 0 plus 1 plus -1. Okay, let's get that in view. Get that in view. There you go. Then we'll have 6 plus 1 plus -6. All right. I didn't have to make it so scrunched up together over here. Look at that. Look at that. Why? Why is this so tightly packed? It's so compact right here. What's going on there? I should have given it like this much room here, but instead, no. Now I'm writing on the. Never mind. Okay, I fixed it. All right. Yeah, let's just go ahead and add this together. So adding this together, we'll end up with our result here. 4 plus 5 is 9, and 9 plus -9, that's 0. Yeah, sure is. -2 plus 0 is -2, and -2 plus 4, it's 2. Then 10 plus 7 is 17. 17 minus 4, or 17 plus -4, okay, it gives you 13. Then in our second row, second column, we'll have 2 plus -3, which is -1, and then -1 plus -4 is -5. How you like that? Okay. Then you'll have 0 plus 1, that's 1, and 1 plus -1 is the same thing as 1 minus 1, which is 0. Okay. We like 0 when we're dealing with matrices. We really do, because it's not as stressful. 6 plus 1 is 7. 7 plus -6 is the same thing as 7 minus 6. You know it's 1. You know it's 1. I'm red boxing this. Red boxing it. Just like that. Yeah. Yeah. This, ladies and gentlemen, this concludes subtracting matrices with Mr. Witt and FBT, Fort Bend Tutoring. If you will, go ahead and like the video. I would appreciate that. Thank you. And also, comment. Yeah, I'd like to talk to you guys, see what's going on out there. And if you're able, please donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and FBT. Peace.
So what you waiting on? Everything is online. Just hit the website, they even got FaceTime. Subscribe to the YouTube, request the video. Watch your math skills go from alright to incredible. They got math, got algebra, got geometry. Pre-cal, calculus, can't forget trigonometry.
And the sum of 6 and -8 will be -2. The sum of -9 and +2 is going to be -7. We have 2 plus 5, which is 7.